Hello to my favorite people ever, whether you are watching this on Monday or the night before our test or on some random night because nothing puts you to sleep like Miss Majorana talking about math. We are going to get right into it. Unit 9, transformations. We are talking about reflections, translations, rotations, and dilations. We are going to quickly talk about the definitions and then get right into it with the problems. If we can make this under 45 minutes, I would be good at my job. So first up, we got reflections. What I want us to focus on when I see the word reflection is this FL right here, because a reflection is a good old F word. What the flip? Transformation that flips a figure over a line of reflection. So if I had a line of reflection, such as maybe this is my y-axis, and I have a triangle over here. When I reflect it over this line, it is just that triangle looking at itself in the mirror. Okay. Next up is translation. With translation, I want to look at this right here because that stands for slide. Translation is when it takes a figure and moves it to a new position. It says without turning it. I like to just think of it like sliding. We either slide it to the right, we could slide it down, we could slide it back to the left. Okay, it's staying in the same orientation, which means this point is always going to be at the top. It's not turning or flipping over any line. It's just sliding. The next one is rotation. Rotation's pretty straightforward. That is just when I am turning a figure. So we talked about how there are 4 turns we can make. We'll talk more about that later. The last one is dilation. When we hear about dilation, I want you to think about an eye, okay? Dilation, like when we get our eyes dilated and our pupils go really big. Dilations are a transformation that changes the size of a figure, okay? So if I took this triangle and dilated it to make it really big or dilated it to make it really small, we don't change the shape, but we change the size. All right, let's get into number 1. Number 1 says the point 1,4 is reflected over the x-axis. What are the new coordinates? So off the bat, I see the word reflected. I know that this point is going to flip over the x-axis. Okay, I'm going to show these problems on a graph. When I scroll down to these graphs, you do not have to copy after me. This is just so we can look at it visually. So I'm going to graph the point 1,4 right here. This is 1, 4. And our problem told me that I'm flipping this point over the x-axis. So this point is going to hop its way over the x-axis. Or we want to think of it like this point is going to look into the x-axis as a mirror. Where is its reflection at? All right. When we did these in class, we took our point and we counted how many spaces, how many units away from the line is my point. So let's count. This point is 1, 2, 3, 4 spaces away from my unit. Okay. If I am 4 feet away from my mirror, my reflection is also 4 feet away from my mirror. Okay. So we take that 4 and go 1, 2, 3, 4 spaces to the other side. Here is the reflection of my point 1,4, okay? Now, what is the ordered pair of this point? Well, my x is at positive 1, and my y, which is on this vertical line, is at negative 4. So I have positive 1, negative 4. All right, so up here, that is going to be D. And the last thing I want to talk about is what is the rule for reflections, okay? We talked about rules looking like this. When I have an X and a Y, what happens to the values of my X and my Y when I reflect it? So we said in class that when I reflect something over the X-axis, the Y changes and becomes the opposite. So this Y would become the opposite. Well, the x will stay the same, okay? So we can see that here because my point 1, 4 and my new point 1, negative 4, well, the x stayed the same, 1 and 1, and the negative 4 is the opposite of positive 4. So let's move on to number 2. Number 2 says that shape TEAM has these coordinates, negative 3, negative 2, negative 3, positive 2, 0, 2, and 0, negative 2. It is reflected, mean flipped, over the y-axis. So determine if each statement is true or false. So let's talk about this using this rule that we thought about up here, okay? But now I'm not reflecting over the x-axis, I'm reflecting over the y-axis, okay? When we reflect or flip over the y-axis, it is going to be our x that changes. My x is going to become the opposite, while my y stays the same, okay? So what does that mean for my different points? Well, 2a says that the coordinates of E prime, remember E prime is going to mean our new E, are positive 3, positive 2, okay? So let's look at our old E. Switch colors. Our old E is negative 3, positive 2. To get our E prime, or our new E, well, x, like we said before, is going to be the opposite. So what is the opposite of negative 3? That is positive 3. And then our y stays the same. So our y is 2, stays the same, 2. So the coordinates of E prime are 3, 2. That is true. The next one says, the transformation rule for this reflection is xy becomes x negative y. That is not true, okay? We said up here that our reflection rule, when we flip it over the y-axis, is that x becomes the opposite. So this is false because here, this shows that y is becoming the opposite. That is false. The last one, 2c, says that the coordinates of m prime are 0, positive 2. So let's see if this is true. The coordinates of regular m, which I'm going to get from right here, are 0, comma, negative 2. What are the coordinates of m prime? Well, our rule tells me that I take the opposite of x. What is the opposite of 0? Well, 0 doesn't have an opposite, okay? 0 is not positive or negative, so I cannot take the opposite of 0. It's just going to be 0. And then I know that my y does not change, so my y stays negative 2, meaning that this one is false, okay? This one I want to show us on the grid, just so we can understand 2c a little bit better. So really quickly, we're going to come down here, and I'm going to graph this for us. My points were negative 3, negative 2 was t. Negative 3, positive 2 was E. Let me get this right, or somebody's going to bring it up in class. A is 0, positive 2. And M is 0, negative 2. So here's my shape, and it says it flips over. Oh, that was ugly. It flips over the y-axis, okay? It flips over this line. So this is easy to think about for T and E, okay? I count how far away is T from the mirror line. That's 1, 2, 3 jumps away. So its reflection is also 3 jumps away. Here is T prime. For E, E is 1, 2, 3 jumps away from the reflection line. So its reflection, E prime, is 3 jumps away. A and M are both right on the line, okay? So when I flip this image over the axis, A and M stay in the same place, okay? A prime and M prime are in the exact same positions as A and M, okay? And this new figure, okay, team prime, flipped over the y-axis, but A and M really just stayed in the same places, okay? All right, let's move on to number 3. Number 3 says a pre-image has coordinates P, 4, -1, E, 0, -1, and 2, 3. It is translated, okay, meaning slide 3 units to the left. What are the coordinates of the new image? So it's a little annoying how they did this, but here's where we are going to graph our points up here, okay? So P is at +4, -1. P is at +4, -1. So 4 to the right and 1 down. I was going to say positive B. Okay, moving on. E is 0, -1. So stay in the center and then just go down 1 is E. And then N is at +2, +3. So we have this triangle. And they tell me it's going to move 3 units to the left. Okay, so if the triangle moves 3 units to the left, that means that each point is going to move 3 units to the left. So point N. This is where it's really important that we're super careful about moving our points, okay? Make sure you, oh, that is not what we want. Make sure you're super careful that you're jumping 1 unit each time. So that's 3 units to the left. Right here is going to be N prime, okay? P, move it 1, 2, 3 units to the left. We got P prime. And then E, move it 1, 2, 3 units to the left. And we have E prime. Here is my triangle translated 3 units to the left, okay? Number 4, what transformation is described by the rules xy becomes x minus 2, y plus 3? Okay, this is one that I want to show us on the graph really quickly so we can remember what these kind of transformation rules when I'm adding and subtracting to x and y do to my points, okay? So I'll remember x minus 2 and y plus 3 down here. X minus 2, y plus 3. And I'll pick a random point. Let's pick 4, 2. 4, 2. So our transformation rule is x minus 2 and y plus 3. So I'm going to take this x, and it says I'm going to subtract 2 from it. So my new point is going to be at +2. Then I'm going to take my y and, oh, we'll do it in a different color, and add 3 to it. So taking my 2 and adding 3, that tells me that my new y is 5. So let's graph this point, +2, +5. +2, +5. That brings me right here. So off the bat, if I look at that rule, we already talked about reflection rules take the opposite, okay? This is subtracting 2 and adding 3 is not taking the opposite of x or y, okay? What's happening here are 2 translations because my point is sliding, all right, in this direction and in this direction. So let's think. The first thing that's happening is it's moving to the left 1, 2 times. All right, think about your x and y axis. Which axis moves to the left? Well, that's my x-axis, okay? My x-axis is the one that moves to the left and to the right. When I am subtracting from x, that's going to indicate that I'm moving to the left. So if we look up here at my rule, x minus 2, that's exactly what's happening here. This point, I'm going to take this and slide it 1, 2 to the left is exactly what happens when we subtract 2 from our x. So this is telling me that I'm translating 2 to the left, okay? Because I'm subtracting from my x. If I was adding to my x, well, that would be going to the right. Then for my y, I am adding 3. So we know that x goes to the left or right. Well, y goes up and down, all right? So if I'm adding to y, well, I can think in my head, it only makes sense that I would be going up, right? And that's exactly what happens here. We move this point 1, 2, 3 units up, all right? So y plus 3 is going to be moving 3 units up. If it was y minus 3, that would be moving 3 units down. So 2 left and 3 up, that is going to be A, okay? Because x minus 2, I want you to write this on your paper. 2 left, because it's a negative on my x, and my y is 3 up, because it is adding to my y. Oh, we did an arrow on the x, so do an arrow on the y. All right, moving on to number 5. Number 5 says the point 310 is rotated 180 degrees clockwise about the origin. Let's think really quickly here about clockwise. Clockwise, like the clock, is when we're turning to the right. 180 degrees, okay, we can think of it like half a circle. It says, what are the coordinates of D prime? I want us to think really quickly. Rotations we don't spend too much time on because it's not too much of our test and they're a little complicated to think about. But when we did talk about them, we talked about how the 4 quadrants, right, have 4 different rules to them. In my first quadrant, which is right up here, my x and y's are both positive, okay? In my second quadrant, well, my x is going to be negative now, and my y is still positive. In my third quadrant, that is when, I don't know, I think it's just 3 of them. I have no idea about the Roman numerals, y'all. X and y are both negative, though. I know that. And then my fourth quadrant, I think that looks like this. My x is positive now, and my y is negative. So we talked about first quadrant being our starting point, our x and our y, okay? When I rotate it 180 degrees, that is going to be 2 quarter turns. Because if I look at this, each one of these is a right angle, or 90 degrees. 90 degrees. 90 degrees. All together, that would be 360 degrees. So if I start in my first quadrant and I rotate 180 degrees clockwise, well, I'll be rotating, I'll be rotating to the right 2 quadrants. And I will end up here where I have negative, negative, okay? The rotation rule for 180 degrees, clockwise or counterclockwise, by the way, because that's also getting us to the third quadrant, is going to be negative x, negative y, okay? So if my point D, 310, is rotated 180 degrees, okay, I'm going to take my x and my y, and I'll take the opposite of both of them, okay? Negative 3 and negative 10. That is going to be answer C. And then let's quickly fill in the rest of these rotation rules because we will use them for the next problem. I'm going to erase these arrows right here. Wrong eraser, please and thank y'all. I would love for us to write these rotation rules on our paper, by the way. So I'm not going to go too into detail with these explanations, but if you see here, this is negative and positive. This is positive and negative, meaning we're only taking the opposite of one. That's the same thing with reflections. With reflections, we only take the opposite of one. But I do not want a rotation to either one of these quadrants to have the same rule as a reflection. So what happens is that y and x swap places, okay? And then they follow the rules. So right here, this is a negative y and a positive x, or opposite of y, and x stays the same. And then down here, y and x flip again. This time, x is the one that is negative, okay? Those are my rotation rules with just some simple explanations. All right, so let's use these rules for number 6. Number 6 says, if a point W, 3, 6, is rotated counterclockwise, okay, counterclockwise, the opposite of a clock, rotating to the right this time. I realize I might have said rotating to the right up here. This is going to the left. Oops. Counterclockwise is what goes to the right. Come on, Miss Majorana. What could the possible coordinates for W be? Okay, so I have this point, 3, 6. I want to go ahead and use a different color and just pretend like I have this point graphed in my first quadrant, okay? So it says it's rotated counterclockwise. It doesn't say how many degrees, so we're assuming it could be 90 degrees or 180 degrees or 270 degrees, which would be 3/4 turns, or 360 degrees. Why not? Okay, so let's think about what would the different ordered pairs be of each of these rotations. Okay, starting with this 90-degree turn counterclockwise. Okay, so this rule is opposite of y, normal x. So right here, I want the opposite of y. Well, y is 6, so the opposite of y would be -6. Here, I want normal x. So normal x, just 3. Okay, -6 to 3 would be a 90-degree rotation. Okay, so that is going to be B. I'm going to write, this is my 90-degree rotation. Next up, let's look at our 180-degree rule. 180-degree rule means opposite of x, opposite of y. So x is 3. The opposite of 3 is -3. And the opposite of 6, which is my y, is -6. So -3, -6 is C. That is my 180-degree rotation. And then last but not least, we got a 270-degree rotation, which is a normal y, so a normal 6, and then the opposite of x, so the opposite of 3, which is -3. That's going to be E, or my 270-degree rotation. If we had a 360-degree rotation, which I was talking about right here, that would just bring us back to 3, 6. It doesn't look like that's one of our options, so B, C, and E are our options for number 6, our correct options for number 6. Moving on. Number 7 says, which transformation changes the size of a figure but does not change its shape? Changes the size. We talked about this in the definitions. I'm going to give us a quick demonstration with a really ugly arrow, okay? So I'm going to take this arrow, and I'm going to do these 4 different transformations with it, and you'll tell me, well, I'll tell me because I'm the one recording this, which one of these changes its size. So starting with A says translation, which is slide. So if I slide my arrow, I can slide to the right or up or down or to the left. The size is not changing. Translation or a slide does not change the size. B is dilation. This is like our pupils, okay? I go to the eye doctor, they dilate my pupils, they get really, really big, and then really, really small. What's happening, people? The size is changing. B is my correct answer. But just to be safe, we'll talk about C and D. So C is rotation. I did not think this through. I did not think how I was going to, well, okay. I could have thought this through a little bit more, guys, but rotation, if I rotated this arrow to be this direction, they're only getting uglier, guys. Oh, in this direction. And it does not change size. And then reflection would be like this guy reflecting itself in the mirror. That does not change its size either, okay? So number 7 is B, dilation. Dilation is the only transformation where we change size. Number 8 says we have a pre-image with these points, which we'll graph really quickly. I have P, which is 1, -3. So that means 1 to the right and 3 down. I just did that for demonstration. Right here is P. I is at +1, +1, so 1 to the right and then 1 up. and G is at -3, 1. So 3 to the left, 1 up. Gives us a little right triangle. Okay, it says it is dilated using a scale factor of 2 centered at the origin. What are the points for this image? So, with a dilation, right, things are getting bigger or smaller. When the factor is 2, that tells me that my image is going to get twice as big. Think about multiplication. That's what happens with dilations, okay? So, to dilate this point, 1, -3, that would be multiplying both the x and the y by 2, all right? So my P prime, I'll write that over here, P prime would be 1 times 2 is 2, and -3 times 2 is -6. So +2, -6 is going to be my P prime. I'll do it in a different color. Hang on. Make it super, super clear what we're doing here, people. Make it super, super clear. Okay, P is at +2, -6. That's down here. P prime. All right, next one is I. Okay, no, U. Y'all, there's got to be at least one mistake. There's got to be at least one mistake. All right, U is at +1, +1. So to dilate it, we multiply by 2. 1 times 2, 2. 1 times 2, 2. So U prime, not I prime, get it together, is at +2, +2. That's right here. And the last one is G, which is at -3, 1. To dilate, I multiply by 2. Okay, -3 times 2 is -6, and 1 times 2, 2. So G prime is at -6, +2. That's right here. So here is my dilated image, which, if we think dilation, we think change in size. My blue triangle, or my image, is twice as big as my pre-image, right? My red triangle. All right, number 9. Kendrick, poor Drake, made a mistake when writing the transformation rule to translate 2 points down 5 units and 3 units right. So here's the rule that he wrote that was wrong. He said x -5 and y +3. What was his mistake, and what should be the correct transformation rule? Well, let's think about translations, which we talked about at the bottom, okay? We know that with x, right, x moves the point to the left and to the right. When it moves to the left, we think negative. With transformations, we would think subtracting from x, and adding to x would move it to the right. With y, adding to y moves us up, subtracting from y brings us down. Okay, so if I wanted to move, the first one says down 5 units, down is going to be, use a third color, down is going to be subtracting from my y, okay? So y -5 would move me down 5 units. Then the second one says, and oh my gosh, my colors are not making sense, people. That was down 5 units. Now we'll do 3 units right in, I don't know, orange. If I want to move 3 units to the right, moving to the right is adding to x. So that would be x plus 3. Oh my gosh, my 5 disappeared. Crazy. Okay. So here would be our rule, okay? Adding to x brings me to the right 3, and subtracting from y brings me down 5, okay? What did he do wrong here? Well, it looks like he just mixed it up. It looks like he subtracted from x. If we subtract from x, this would bring me to the left 5. And he added to y, which would actually bring us up 3, okay? That was his mistake, is he put the -5 and the +3 in the wrong places. Number 10 says, For numbers 10a through 10c, determine whether each statement is true or false using the transformation rule xy to 1/3 of x, 1/3 of y. All right, fractions, they scare people away, but they're really just ways for us to either multiply or divide. Here, I'm looking at 1/3 side by side with both x and y. That tells me multiply. What I want us to think in our heads is that multiply, when we're multiplying x and y, that is a dilation, people, just like we saw with multiplying our points by 2. Okay, if I had an x and a y, like, what do I want to do? 9, 12. Okay, and I transformed them with this rule, 1/3 x, 1/3 y. Well, I would want to transform it 1/3 times my x, which is 9. 1/3 times my y, which is 12. Check out this pro move. I got my calculator right here, people. So I'm gonna put this in my calculator. 1/3 times 9 is going to be 1 ABC 3 times 9. I know what you guys are thinking. This is so cool, Miss Majorana. Equals 3. Okay, 1/3 times 9 equals 3. And 1/3 times 12, 1 ABC 3 times 12 equals 4. So 9, 12 would transform to 3, 4. We would find something that is 1/3 as big. Okay, so 10a says this transformation represents a dilation. This is true because we are multiplying our x and y values. B says this transformation forms an image that is congruent to its pre-image. Congruent, I hope we know, is same. Congruent means same shape and same size. That is not what we have here, okay? If we use the word similar, that would be true. Remember the ugly baby picture. The ugly baby stayed the same shape, but not the same size. Okay, dilations produce similar images, not congruent images. And the last one, 10c, says the image will be smaller than the pre-image. Well, if I multiply by a fraction, just like we saw down here, 9, 12 goes to 3, 4. This is true, okay? Our points become smaller, meaning our shapes will become smaller too. All right, we're rocking and rolling. Number 11 says rectangle M, 1, 3, 1 to the right, 3 up. A is 6, 3, 6 to the right, 3 up. R, 6, 1, 6 to the right, 1 up. Oh, my bad. And S, 1, 1, 1 to the right, 1 up, is reflected over the x-axis. So graph the image after undergoing the transformation. So let me connect my points real quick. And we want to see a reflection over the x-axis. This is going to be my mirror line. So just like we saw a couple problems ago, I'm going to count how far is each point from the mirror line and then count that much further. For example, with R, I'm going to count 1. It is 1 jump away from the mirror line. So its reflection is going to be 1 more jump over, okay, R prime. I remember what I learned from teaching this was erasing the jumps in between or else it gets super messy. So I hope that does not confuse you. Next up is going to be A. A looks like it's 1, 2, 3 jumps away from the x-axis, meaning its reflection is also 3 jumps away from the x-axis. There is A prime. Erase my jumps. Next, we'll do M. M is 1, 2, 3 jumps away as well. So 1, 2, 3 jumps away. Notice that as I'm doing this, I am not just, jumping 1 and then drawing my shape in, okay? We're only taking one test on this, people. It is not the day to be lazy. That is not the day to be lazy. You'll be lazy any other day. None of my business. Let's not be lazy during this test. All right, here's my reflected shape, or what we call an image of my shape over the x-axis. All right, number 12. A pre-image has these coordinates, 3, -6, and -1, -2. The image has the coordinates +6, 3, and +2, -1. Describe the clockwise, okay, to the right. Miss Majorana, that is to the left. Clockwise is to the left. I'm going to drill that into my brain. Clockwise is to the left, Miss Majorana, of the rotational path. All right. So let's think. We have J, which is 3, -6, and K, which is -1, -2. And they rotate so that J prime is +6, 3, and K prime is +2, -1. J prime, K prime. So I'm going to take this. I'm going to give you a second. No, pause it to write this down, but I'm going to keep moving because my goal was 45 minutes and I don't think I'm going to make it, people. You guys are looking at the time right now. It's probably like 55 minutes and you're like, yeah, Miss Majorana, you did not make it. All right, so we have JK. Let's graph our original ones. +3, -6 is here. And K is -1, -2. Right here. J and K. It looks like this is just a line. And then it rotates clockwise, meaning to the left, not to the right. So that K is at, J prime is at +6, +3. J prime. And K prime is at +2, -1. Oh, did I do something wrong here? I did something wrong here. I hope you'll forgive me. It is 9:29 at night. I graphed K, the original K, wrong. My bad. -1, -2. Now, I don't want to hear anything because the way some of y'all graph, I don't want to hear anything about that mistake. J prime, K prime is this line right here. Okay. So if you'll notice, how do my points move? All right, so J is moving from this quadrant, one quadrant to the left. K is moving one quadrant to the left, okay? One quadrant or 1/4 turn is just a 90-degree turn since it is to the left. Oh my gosh, hang on. Okay, you have full permission to roast me in class. To the left will be this way. This has got to be the most challenging thing for me. Okay, so one more time from the top. I have J and K. J is moving to the left, which is this way, Miss Majorana. 1 quadrant, 2 quadrants, 3 quadrants. The same thing with K. K moves to the left, clockwise. 1 quadrant, 2 quadrant, 3 quadrant. 3 quadrants is 3/4 turns, or 90 plus 90 plus 90 is 270 degrees. So clockwise to the left, this is a 270 degree rotation. I'm so sorry for that horrendous mistake. But we are lucky that I caught it now and did not have to correct it in class. So clockwise 270 degrees is going to be the rotational path. Clockwise 270 degrees. If we had, made the mistake like we did before, it would just be counterclockwise 90 degrees. Like we said, when I kept saying it was going to the left, it goes to the right, just 1 quadrant. What I was saying before with that, it would be a 90-degree counterclockwise, okay? All right, take a deep breath after that one. There's only 2 more, thank goodness gracious. All right, so I have triangle SUN with these coordinates. What are the coordinates for the image resulting after a dilation with a scale factor of 1/2? So one more reminder that the factor is what I'm multiplying my points by. So I have these points S, U, and N. 2, 2. It is too late for me to be recording this right now. 2, 6, and 4, 2. All right, my factor of 1/2 is what I am multiplying by, times 1/2, times 1/2, times 1/2. I'm not going to break out my calculator, but just a reminder, to type in 1/2 to my calculator, I would use this ABC button, 1 ABC2. So what is 2 times 1/2? That is 1. 2 times 1/2, 1. S prime is 1, 1. U, 2 times 1/2 is 1. 6 times 1/2 is 3. U prime. And N, 4 times 1/2 is 2. And 2 times 1/2 is 1. N prime. Here are my dilated points, okay, after my dilation of a scale factor of 1/2. Last but not least, people, Kira proves that 2 figures are congruent after using transformations. Congruent is our key word. Remember, same, same. If she finds out that they are congruent, that means that they are going to have the same shape and the same size. Which of the following might she have done to prove this? A, she mapped one figure onto the other using translations and reflections. So she'd say, if I had these 2 triangles, I know that they are congruent because I I slided this triangle, to the left, and then I flipped it over a line that looks like this. We're moving on. B, she mapped one figure onto the other using a series of transformation, including a dilation with a scale factor other than 1. So if I dilated it with anything other than 1, remember, if I multiply something by 1, it stays the same. She's saying we multiplied it with something different than 1, so maybe like multiplying it by 3. If I took this triangle and multiplied it by something other than 1, either something bigger than 1, making it bigger, or smaller than 1, making it smaller, well, that would not be the same size. That would not be congruent. B is incorrect. C says, mapped one figure onto the other using a dilation with a scale factor of 4. Once again, that dilation, oh no, does not keep the same size. All right. D, she cannot prove 2 figures are congruent with only transformations. Well, I know that that is not true because we did that with this problem right here. We said that these points were congruent because I used a translation to be specific, to map it onto each other. So D is not correct. That leaves us with A. All right, so we struggled a little bit here, but overall, I hope that this was a good review of transformations for us. I know that geometry can be a little tricky. Personally, I am an algebra girl, tried and true, but if you have any questions, please send me a message in Canvas. Please let me know in class. We are almost there, people. There is one more unit left. I'm so excited to see you guys shine on your test, and I hope you have a great day. Goodbye.